In this problem, sulfuric acid is spilled on a lab bench, and you can use sodium bicarbonate to neutralize the acid, which gives off carbon dioxide, water, and sodium sulfate. If 27 milliliters of 6 molar sulfuric acid is spilled on the counter, what mass in grams of solid sodium bicarbonate must be added? So in order to answer this, we first need to have a balanced chemical equation. So if we have sulfuric acid, which is aqueous, plus sodium bicarb, which in this case is a solid, we're going to get CO2, which is going to be a gas, plus H2O, liquid, plus sodium sulfate, which is going to be aqueous, as it is soluble. So we also need to make sure our equation is balanced. And so if we look on the left, we can see that there are 2 sodiums, where there's only 1 on the right. So we're going to go ahead and add a 2 here. When we do that, we need to have 2 carbon dioxides. But if we briefly check this through, the other one we need to look at is the water. And so we have 2 hydrogens plus 2 hydrogens here, which is 4, which gives us a 2 here. And so that's a balanced chemical equation. So now we can treat this somewhat similarly to a titration problem, where we want to know what balance between these two. Now the trick is that you can't use M1V1 equals M2V2 for a couple of reasons. One, solid and aqueous, those are not both volumes, and oftentimes that doesn't take into account the stoichiometric ratio. So first we're going to take our 27 milliliters of sulfuric acid, and we need to figure out how much sodium bicarbonate will neutralize all of this. And so we know that these need to be in a 2-to-1 ratio if we were just using 2 solids, kind of like we have in chapter 3. So we want to convert this to liters using in 1 liter, there are 1,000 mils. Then we want to determine how many moles there are. And so we're going to use 6 moles in 1 liter. That comes from the molarity, right? So molarity is moles per liter. In this case, when we plug it into our calculator, we get that there is 0.162 moles of H2SO4. So now we want to convert moles of sulfuric acid to moles of sodium bicarb. So 0.162 moles of H2SO4. Now we want to use our stoichiometric values. So 1 mole of sulfuric acid is equal to 2 moles of sodium bicarb, okay, or sodium bicarbonate, yeah. And so when we multiply this by 2, we get 0.324 moles of sodium bicarb. Now we need to convert this into grams because the question asks what mass in grams. So in order to do that, we need to use the molecular weight. Well, we haven't been provided the molecular weight, but we can. So the molecular weight is equal to 22.99 plus 1.01 grams. So this is the sodium, this is the hydrogen. And then 12.01 grams for the carbon, and 3 times 16 for the oxygen. So when you add those into your calculator, we get 84.01 grams per mole. So we can plop that right up here in this equation. So we have 84.01 grams of sodium bicarb per mole. And so if we multiply that by the moles that we have, we get that we need 27.219 grams, and we want to make sure we double check our significant figures. So we have 3 in the volume and 2 in the molarity, so we can only have 2 here. So if we use our sig figs, we need to add 27 grams of sodium bicarb to neutralize the 27 mils of sulfuric acid. Whoops, you could not see that at all. So here we go. Just to refresh, since I forgot to move it up, we took our molarity and converted it to grams. Now here's how you would calculate the molecular weight. We summed up the sodium, hydrogen, carbon, oxygen, and got a molecular weight. And we multiply it through here. So just to give you another shot, since I doubt it was on camera, we took our 27 mils, converted it to liters, used the molarity to determine the moles of sulfuric acid. We then did a mole-to-mole calculation using the stoichiometric values from our balanced chemical equation up here at the top to get 3.24 moles of sodium bicarb. Once we did this, we were able to determine the molecular weight, which gave us the mass in grams.